Curious, engaging, the modern world relies on an invisible backbone. From the vitamins we take to the plastics in electric vehicles, almost everything we consume requires basic chemicals like ethylene, a simple hydrocarbon that acts as the primary building block for industrial manufacturing. The machine responsible for creating these basic chemicals is called a steam cracker. These are enormous industrial furnaces stationed at the very beginning of the global supply chain, designed to break raw hydrocarbons down into smaller, usable molecules. That process comes with a massive environmental cost. Because steam crackers generate their extreme heat by burning fossil fuels, they are the single largest source of greenhouse gas emissions in the entire chemical sector. Because these machines feed the base of the global supply chain, you cannot build a truly clean manufacturing economy without first decarbonizing the steam cracker. In 2026, the European Union is activating an economic shockwave called the Carbon Border Adjustment Mechanism, or CBAM. CBAM is a regulatory framework designed to price carbon emissions out of the market. The mechanic is straightforward. It functions as a strict tariff levied on the embedded carbon emissions of any imported goods entering Europe. If your manufacturing process is dirty, you pay a heavy penalty to sell your product. This creates an existential threat for export-heavy nations. Take South Korea, for example, whose massive industrial output relies heavily on high-emission liquefied natural gas to power its manufacturing. This chart shows the projected financial burden of the new carbon tax on South Korean exports. Notice the massive spike on the far left. Heavy sectors, specifically petrochemicals and steel, will face the highest, most crippling financial burdens under this new mechanism. CBAM turns carbon reduction into a requirement for survival. For any nation relying on exports, clean manufacturing is now the baseline for staying in the global market. To decarbonize a steam cracker, you have to solve a brutal engineering hurdle. Breaking down long-chain hydrocarbons requires continuous, extreme temperatures of around 850 degrees Celsius. Historically, the only way to reliably generate and sustain that much heat at an industrial scale was burning massive quantities of coal or natural gas. To solve this, a multi-million-euro collaboration between chemical giants BASF, SABIC, and Linde has successfully built the world's first large-scale electric steam cracker. This demonstration plant is the critical proof of concept required to decouple extreme industrial heat from fire. The new facility uses 6 megawatts of renewable energy to process 4 tons of hydrocarbons every single hour. To figure out the best way to scale this up, engineers are testing 2 different architectures. The first is direct heating, where an electric current is applied straight into the reactor's process pipes. It uses the natural electrical resistance of the metal tubes to force the material to generate extreme heat from within. The second method is indirect heating. This approach places electric radiant heating elements around the outside of the pipes, functioning much like the heating coils in a standard electric oven. The consortium is running both methods simultaneously to determine which setup is the most reliable and flexible for high-volume commercial demands. The engineering delivers a clear payoff. When powered by renewable electricity, this electrical heating process cuts the direct carbon dioxide emissions of basic chemical production by at least 90%. There is a catch. An electric furnace is only emission-free if it is plugged into a massive, reliable grid powered entirely by wind, solar, and hydro, and simply plugging in isn't enough to make the economics work. Survival requires deep systemic efficiency. BASF operates under a philosophy they call Verbund, a German word meaning to be connected. In a Verbund system, an entire industrial site is intelligently interconnected so that the waste heat and chemical byproducts of one plant serve as the direct fuel for another. Achieving net zero in heavy industry requires abandoning the old model of standalone factories in favor of highly optimized, interconnected renewable ecosystems. The successful startup of the e-furnace confirms that electrifying high-temperature chemistry is a functional reality. The technical barrier to clean, high-heat production has been removed. This technical validation arrives at the exact moment international carbon tariffs, like the EU CBAM, are set to penalize dirty manufacturing. The new rule of global economics is set. Companies and nations that successfully electrify their processes and integrate renewables will command the future of international trade. Clinging to fossil-fueled infrastructure is a mathematical guarantee of being taxed out of global existence.